I am Christine Hermelwan, the head of product growth at Embrace. I've been with the company for 4 years since the very beginning, and I've worked with small and large mobile development teams. And I've basically seen a lot of teams grow over the time period and seen a lot how mobile has changed. And because I work so closely with the teams, one of my favorite things to talk to them about is how to improve their startup, especially when their teams are growing, they're expanding into new markets. This tends to be a KPI that is of big interest to them. And so I'm really excited to share with you the insights that I've gathered from conversations with different teams, from seeing startups from different teams, and share that knowledge with you. So first, I'm going to frame the webinar. These are the questions that we're going to answer during this next hour. So 1, why should you care about your app's startup time? What is the business impact? And why is this affected by mobile users and their behaviors? Next, what is even an ideal startup? What does that look like? How long does it take? What is the benchmark that your team should be aiming for? Next, how do startup times get bloated? What are the main culprits of this? Next, how the right tooling can help you actually improve startup times. And then finally, the last segment of the webinar, we'll talk about what you can actually do right now to improve your startup times. So let's get started. So why is mobile so important? Why do we care about it? Why should you care about your mobile app? Global app revenue reached $50 billion in the first half of 2020, which is up 23% year over year. We've definitely seen that with COVID, it has accelerated the revenue that comes from mobile. We had one of our home improvement retailers talk to us about their traffic on their mobile app. And when lockdown first started, the traffic on their mobile app exceeded that of every single Black Friday that they had ever seen. And now it has actually leveled off to a higher base point. So instead of maybe seeing 1 million users, they're seeing 1.2. It's definitely, when people had that great experience on the mobile app, they decided to stay. Nearly 3/4 of the world will use their smartphones to access the internet by 2025. The shift is really moving towards mobile. People are not really using their desktops as much, and mobile is really the way to go. And lastly, the split between revenue on mobile and desktop is 65 to 35 in favor of mobile. So on top of that, when I've talked with my e-commerce customers, what they've told me is it is easier to retain people on mobile, and it is also, they have higher average cart values on mobile as well. A really big thing with mobile and desktop is that I am always on my phone, and a great way to engage with people is through push notifications. And so with push notifications, people being on their phone all the time, higher average cart values, really the focus is shifting towards mobile. And I've seen this really across the past 2 years, that a lot of people are investing more money in their mobile teams. Teams that used to only have 2 to 3 mobile developers are now at 15 to 20. So we are also starting to see these companies shifting and putting more resources towards their mobile teams. So why are startup times so important in general? Amazon did a study, and this was for web, but they they found that for every 100 milliseconds in latency, it costs them 1% in sales. So the slower your app is, the less revenue you'll get, which makes sense. People get frustrated and they don't even enter the funnel. If your startup is slow, then they may not even continue with the app. And mobile users are very demanding. They have no tolerance for bugs or UI issues, and 1/4 of end users abandon mobile apps after their first experience. They're pretty unforgiving. What we've also seen is that it's not about stability anymore. For our mobile teams, it is really about performance. So when I have 2 competing apps on my phone, for example, a DoorDash and a Postmates, I have a lot of apps that are very interchangeable on my phone. If DoorDash for some reason doesn't load quickly enough, I will switch over to Postmates immediately. So not only is that I will lose, DoorDash may lose me as a customer, it's that I will go to Postmates and maybe my loyalty will be to Postmates because their app is faster. We've also seen during Black Friday with a similar retailer, when their competitor's mobile app was down, they noticed it because they saw a spike in their traffic and they welcome it. They say that they got extra revenue because their competitors weren't looking at their mobile app. So their failure, their competitor's failure was their gain. So what does the ideal startup look like? This is where I talk about like what the benchmark looks like. And this is what I've seen across multiple apps, across many industries. There are small variations, but really what you're looking at, you're balancing the tolerance of your users and the great experience of your users being able to get to your app as quickly as possible. So the way that I define startup is from when you tap on the icon to when the user can first interact with the app. So when I can first press a button or type something in the search bar. Startup doesn't end when you see the splash screen. I can't do anything with a startup, with the app then. So when we're timing this, we're talking about from when they tap on that icon to when they can first interact with the app. And so the benchmark for that timing is less than 2 seconds. So I'm gonna let you guys sit with that for a minute and think about your mobile apps, your own mobile app and the mobile apps that you use on your phone, and think about whether or not your app has a startup of less than 2 seconds. It's a pretty aggressive time, and the only way to have a startup that's that fast is to strip the startup down and all of the things that happen in the startup to the bare minimum. You want to minimize the opportunity for errors, you want to minimize the opportunity for slowness, and to maximize just the efficacy of the startup. You really want the users to get to the app as soon as possible. And what's also very important, I think that a lot of people don't think about, is when you're entering into new markets, what does that startup look like? If your primary market is in the US, maybe your startup is great and it's less than 2 seconds, but you're entering into a market in Southeast Asia for growth. What does your startup look like there? How have you accommodated to the different environments there? Is it still less than 2 seconds there, or is it longer? And oftentimes it's longer. So what blows up startup times? What prevents you from getting to the point where you are over 2 seconds? Most of the time, it's unnecessary SDKs, unnecessary processes, or network calls in general. And what they do is everything that is unnecessary during your startup is an opportunity for an error to occur or a slowdown to occur. So these are the common issues that I typically see when we onboard a new app. This is one of the first things that I like to check. I do check the startup because it is, for myself and my team, the easiest place where I can provide value. I can look at a startup because I've worked with so many companies that I can very quickly identify how they can reduce startup times. So the first one is networking calls blocking critical first-party APIs. So this one is very surprising to people. They don't even think that it can happen. So an example of this is a food delivery app that we work with. So you can imagine if I'm logging onto it, the first screen should allow me to search for restaurants. But at the same time, what they're trying to do is determine my location. When they first onboarded, we noticed that some of their startup times were excruciatingly slow. And I dug into it. And what I found out was that the Google location services, basically identifying where the location of the person was blocking the calls that would show the search screen. So instead of immediately allowing someone to search for a restaurant and then giving them the error of, hey, we don't have connectivity, try again, they were stuck on the splash screen because that Google call was blocking the call that would load the search bar. And this was a big game changer for them. When they realized that it was actually blocking their first party API calls, they switched the order. They took the location networking call and they moved it out of startup. What they decided to do is say, okay, we're gonna load up this home screen where people can access the search bar. And then if they don't have connectivity, when they press search, we'll just tell them that they don't have connectivity, rather than people thinking that this app is broken. Congestion. This is a very interesting one because if you look at each call individually, it may seem like they're still firing off pretty quickly. Each individual call in itself looks like it is firing off very quickly, but it's just kind of like a traffic jam. If you have too many network calls firing off at the same time, it actually slows them all down across the board. And where we see this happen the most is actually with teams that are very interested in pretty much tracking metrics for their marketing team, their product teams, and they have a ton of third-party SDKs. And so what they do is they have 5, maybe even 10 SDKs starting up at startup, and they're all firing network calls at the same time and slowing everything down. And so they're actually trying to get numbers about how to be better, but what they don't realize is every SDK that they add actually slows down the startup and makes the performance of all of their important funnels actually worse. The next is poor caching and re-downloading unnecessary assets. This is really big with media. So we work with a very popular online dating app, and if I am opening my phone, maybe I want to always be able to access those messages, and that's always something that I want to be able to access quickly. You don't want to have your users re-downloading it over and over and over again. You want them, if it's something that they're going to access very regularly, to just always be there. This came up when I was talking with their team. I noticed one of their calls was very slow, and I pointed it out to them, and they told me, they were like, oh, we knew it was slow, but we didn't realize it was that slow. They eventually had to go to the back end team, figure out how to better cache and improve their call speeds. And lastly, similar to what I mentioned before, just any unnecessary and excessive networking calls. We have seen situations where someone will leave an SDK in and there's poor retry logic, and you end up getting repetitive calls over and over and over again. I very frequently see duplicative network calls. A lot of my customers don't realize that their calls are duplicative. So these are the common things that I've seen that have bloated startup times and prevented people from hitting the less than 2 second benchmark. So you might be wondering what type of mobile teams struggle with these issues. And it's the best ones. This is what has been very interesting to me. Teams that are tiny and lean, they keep their startup tight. It's super fast and it's pretty targeted. What happens is that when you are getting these more mature teams, you're adding more to the startup because you're trying to make this experience as great as possible. You want to have preloaded images. You are putting ads in for revenue. You're putting product and marketing SDKs so that you can figure out attribution, or you want to track the funnel. And all of these things, which are key to your growth, are actually slowing down your mobile app. And the problem is it's a very hard issue to identify. And where it manifests and where it starts to actually become a pain, I've seen, is where mobile teams are starting to grow the fastest. It's when they're entering new markets. For example, the dating app I was telling you about, their startup times in the US, because they're primarily US company, they're great. They went into India and they were getting terrible reviews, absolutely awful reviews. And it's because certain things that are okay in US conditions are absolutely not okay in India. They had to make it more lean. They had to cut it down. And in order to expand, they had to understand how to pare down what they already had to work with the conditions that are not ideal. I've also seen this happen because mobile teams are growing. Like I mentioned before, mobile teams that are maybe 2 to 3 people are now 15 to 20. Now you have 15 to 20 people touching the code base, not realizing what impact their code has on other parts of the app. The other part is people who are running experiments and trying to optimize monetization. They are also experiencing these issues because they're assigning these experiments at startup. And sometimes people are getting stuck. These SDKs may not be the best, and what they're doing is they're reducing the time, they're reducing the people coming through the funnel because people are getting stuck at startup. And so what's crazy to me and what is very fascinating to me is that these mobile teams are starting to realize the importance of startup when they're really focused on performance. And these issues that I've talked about have actually been problems for a very long time. And it's just very difficult to identify. And so they start to feel the pain the most when they're growing the most. So how are these mobile teams missing these glaring errors? Like I talked about before, as teams grow, it's more difficult to manage code quality. These teams were used to being 2 to 3 people where they knew the entire code base. They knew everything that went in and went out. And as they're growing, I'm seeing a lot of mobile teams have growing pains because they don't quite know how to manage code quality with all of these feature teams. It's really common, and it's because it's been a more recent phenomenon that these mobile teams are getting so large. Lack of visibility into third-party SDKs. This is code that your mobile team does not manage. It is a black box to them. They don't know how these third-party SDKs are getting the information that they are getting. They don't know what processes they're tapping into. And we've witnessed with other third-party SDKs is that they don't necessarily follow best practices. And it may not be your team's fault. It just purely may be that the third-party SDK doesn't do things properly and messes up. And if you initialize it at startup, it could lead to very bad consequences because it's code that you're not familiar with. And lastly, there's just a heavy reliance on back-end monitoring. And what I commonly run into when I talk with some mobile teams is when I ask them, how's your mobile app and how do you monitor it? They tell me that they monitor their back-end API and everything looks great. But what happens on your servers is very different to what happens on a user's device. And that's a really big, it's a really big thing to notice. And it's a really big learning that I do have to educate a lot of VPs of engineering on. The tooling for backend monitoring is great for servers. It is perfect. It's wonderful. We use Sentry, we use Datadog for our own backend monitoring, but it is not the greatest tooling for mobile. And so I'll go into that next, which is just at the core of it, how are mobile and desktop different? So with servers and desktop, you have all of these servers that have a very fixed environment. And then when you make any changes to a website, you can push them out immediately. The environment is very controlled, and so there are very few variables that you can change in this to improve what goes out. Now think about your phone. I have an iPhone, you may have an Android. The number of devices in itself, so many. You have hundreds of Android types. You have iPhones, you have tablets. So even the first comparison between servers versus devices, you already have a lot of options on mobile with the types of devices that you are running on. And on top of that, you have environmental differences. I could have my phone in low power mode, and that can affect how the app works. It affects how the operating system works. I can have different versions of the operating system. If I am on an older operating system, it may work better or worse, probably worse than a newer operating system, but that's another variable. And then the very common variable that we all experience is poor connectivity. Even my same phone will act differently and interact with an app differently when I hit a dead spot. So all of those variables you experience in mobile, it creates an exponential explosion of the different types of environments that you could possibly test on. And this is why it's so difficult for mobile developers to have an idea of what's going on in their app. They have so many different things to think about. It's not that things are firing in a very predictable sequential order. It could be that you're in the middle of one process and you walk through a dead zone, and then you get reception again and it triggers another process. It's so difficult, and mobile developers are not equipped with the right tooling. So what I'm gonna do is kind of go through examples of like what I talked about with, third-party SDKs that are blocking, and then compare that to how I'll show you what that looks like on your backend when you're monitoring this. And then after we go through all of those examples, I'll show you what it looks like on Embrace and why it's different. And it'll give you an idea of why mobile teams miss it, why it's such a seemingly simple, but actually very difficult thing to improve your startup time in practice. Okay, so this is if you have a third party like a Google blocking your first party API calls. It basically looks like there are no errors. There is nothing particularly special that will pop out. You won't have a 500, you won't have a 400. Even if it's blocking, it'll actually be a pretty quick networking call. Or you may have a connection error, but you really won't see anything on your backend that would point towards this being a problem in your startup. Network congestion. So I talked about this a little bit before. This is when you have multiple networking calls firing off at the same time. You may see a slight increase overall in your response times, but you won't actually be able to feel it, and it'll be across the board. So it won't really look like anything is wrong. When I'm talking about network congestion, it just means a bunch of network calls firing off at the same time. They're not necessarily erroring out. They're just all rushing to the same place at the same exact time and slowing each other down in the process. Device side connections. This is when I experience this, and when I talk to teams a lot, the mobile team definitely feels this pain. The server side will say, yes, it's perfect. I sent out the API call, it was quick, it was a 200, it's great. Except as a mobile user, I'm walking through a dead zone and the app can't process it. It's going through, I have no connectivity, and my phone is trying and trying and trying, and it tries for 10, 15 seconds, and then there's a timeout. I've worked with numerous mobile teams that have not coded for these timeouts because they don't expect them to happen. Because when they're testing in this perfect environment where they're on Wi-Fi, they're on their own phone, or they're on the newest Android or iPhone. And it's just really not the same experience as walking on the street with the most common type of phone that you could get on the most common operating system that most people are on. And so what happens is that these teams miss it because their servers say, yes, I sent the information over. But when it comes to the user and the environment that they're in, it actually creates an error because they don't have reception. Now, let's take a look at these in Embrace. So I've pulled up what we call user timelines. And this is how I would see those same situations in Embrace. So we've changed, these are real startups for real apps. But what we have done is that we have changed it so that you can't figure out which app it is for. So here is one that you can see. So this is one where it is for a startup that put in a ton of third-party SDKs for monitoring. So this one has a lot of congestion. This is one where they put in all of these third-party SDKs because they had all of these different teams that wanted to capture all of these metrics, and the mobile team just kept putting it in and putting it in. And each additional SDK doesn't seem like a big deal, but in aggregate, it produces an overall slowdown effect. So what you can see is this startup took 16 seconds. This is for a banking financial app. So the first thing that I notice is this person's on Wi-Fi. It's not even like they have poor connection. And then you can start to see what is happening here. They have use button, they have Crashlytics, they have a data analytics, they have segment, and all of these are sending, they have apps flyer, and all of these are sending all of these events during startup. All of the SDKs will tell you that they should be initialized at startup so that they can grab as much information as possible. But now think about if you add every single SDK into your startup, what it looks like. Again, apps flyer, Firebase, the CPU is starting to peg. More calls from segment, apps flyer, branch. And it takes 16 seconds for this startup to finish. It's crazy. This person probably tolerated it because it was a banking app, so maybe it's very important. I need to upload a check. I need to check my bank balance. But really, you can see very few first-party calls here. And so what I suggest to people is keep your startup as slimmed down as possible. Only put in SDKs that are measuring stability, like ones where if your app crashes at startup, it catches that and lets you know. Most other things can wait. They can wait to be loaded. They can wait to start pushing all of this stuff. You want your user to get to your app as quickly as possible so that they can interact with it and get the value out of what they need. And I'm still going down. And so this is, 16 seconds later, this is when they get onto the landing screen. This next timeline I'm going to show you is even worse. It's where the startup was 28 seconds. Similarly, this is for a large company. And so this one has internal teams that produce SDKs for content and videos, as well as external SDKs to track for logging and monitoring and some data analytics stuff. Here, you can see that they're on Wi-Fi again. Ton of calls. Here, we start to see duplicative calls. Again, you'll start to see more duplicative calls. They probably have a lot of people working on this app and it's trying the same thing over and over again. So these calls are unnecessary. And the big one is right here. What you'll notice is that the timestamp on here is at the 28-second mark. there is a connection error, meaning for some reason it couldn't connect and it kept on trying and trying. And the next call wasn't made until the 54-second mark. So there was 26 seconds where nothing at all was happening. This is where I'm telling you third parties are blocking. Whatever this is trying to do, it has blocked anything else from happening on the app. And as you could see from the previous graphs that I showed you, when you're looking at things in aggregate, what does this show up as? One connection error. It doesn't show up as a 400. It doesn't show up as something that took 28 seconds or 26 seconds to happen. You got the connection error probably relatively quickly, but what you don't see, because you're not seeing all of the detail together within a user experience, you don't get to see this gap. You don't get to see that it has literally blocked the app from doing anything else. This is where people really start to understand why mobile is so complicated. You can't just aggregate everything and track error rates. It's really the interaction of all of the things that are happening in the app, in the numerous environments that make this so complicated to troubleshoot. So if you have customers that are complaining about performance issues, something like this could be happening. And this is why, and because your tooling doesn't get down to the individual user experience, this is why you're missing it. This is a very specific thing, but it has an extremely large impact. When I showed this to the team, they were very shocked. They want to go to their backend team, talk about the timeout. They wanted to talk about, like, reach out to them and see what was going on. And this was a big problem that we uncovered. Again, like even something like multiple network calls, because it's a very consistent thing across every single startup, you won't see any blips. You won't see any general increases or spikes in errors or network calls. It's very consistent across the board. But what you will experience is an overall slowdown. So if you have 40, 50 network calls firing off at the same time, what it'll do is it'll just incrementally slow everything down. And maybe your startup will slow down by 100 milliseconds, 200 milliseconds, 300 milliseconds, and you get an overall degradation. And it's kind of a slow process, which is why a lot of people don't notice it. But when I do talk with people, what they have noticed is they want to track this because they know as time goes on, you keep on adding one more SDK, you change the way startup works, and if you're not tracking it on a regular basis, you won't know if it's getting better or worse. So what actions can you take now to improve startup? First, audit all the SDKs in your app and remove any that are unnecessary. I have seen great apps where they have an intern as a project put in a third-party SDK, and the intern did not take it out at the end of the internship. And then there was terrible retry logic. Audit the SDKs in your app, remove any that are unnecessary, and if there are any that are initialized during startup, reevaluate whether or not you actually need them initialized at startup. Maybe you can initialize them later so that they don't affect the startup time. 2, understand the environment of your typical user and try and test with that environment. What I see is that a lot of people will test with the newest iPhone, the newest Android phone, but really their user base may be on old iPads. Their user base may be on maybe 2 generations of iPhone, ago, and maybe your user base is typically walking around. They're not connected to Wi-Fi. Your developers should test in that environment, and that will help them catch some of these issues that may happen in startup. One of the things that very much doesn't happen when they're testing is all the network calls fire off in the right order. And sometimes when you go outside and you test under real conditions, you notice that sometimes they can fire off in the incorrect order, and it produces blank pages. So I highly recommend that you understand what your typical user's device and environment looks like and replicate that during testing. Oh, and then the last point is to track the performance of metrics on the device. Don't just rely on your back end monitoring. Something that can be very quick on the server could be very slow when it reaches the phone because maybe there are already 40 networking calls queued there. So don't solely rely on your backend performance. Monitor the performance on the actual device.